Hello, these are flipped notes 5-5 of our cognition unit. And in this one, we're talking about thinking and problem solving. So my Bitmoji here is trying to solve some math problems in her head. But we're not really getting into math in this section, just thinking or cognition in general. So we just finished up talking about language, and thinking and language are very much intertwined. We need to think in order to have language, but we also need to know language in order to think. Or do we? What do babies think about if they don't know language? How do they think? Do they just think in images? Sapir and Worf talked about how language influences thinking, and they had what we call the linguistic relativity or Sapir-Whorf hypothesis. He suggested that language determines the way we think, that basically, if we don't have the words for it, we don't think about it as much. But things that we do think about a lot, we have more words for. For example, he noted that the Hopi, an indigenous tribe, don't have the past tense for verbs. So they don't readily think about the past. He also related it to the Eskimo or the Inuit, that snow is so much part of their culture that they have so many more words for snow than what we know for snow. And we'll look at that list during class. Sapir-Whorf took it even a step further and came up with linguistic determinism, which is a more extreme form of relativism. He said not only does language influence our thinking, he said language can also determine how we see the world, that it really actually influences our perceptions, and we can't see things another way if we don't really have the language to go along with it. So, for example, he said not only do the Eskimo have different words for snow, he said they can actually perceive snow more differently because they have more words to identify it. We can kind of see that here. When a language provides words for objects or events, we can think about them more clearly. Like if I asked you to describe what these colors are, if you know lots of more words for types of blues, it's easier to distinguish them. So it's easier to think about two colors with two different names, blue and green, than colors with the same name. But think of all the colors for blue in between there. We'll talk about those in class. So thinking, we know our fancy word for thinking is cognition. We've talked about that since the beginning of the year, but it's a process that involves knowing, understanding, remembering, and communicating. When cognitive psychologists look at cognition, there's a bunch of, or the main mental activities that they look at are concepts, problem solving, decision making, and judgment formation. So a concept is just a mental grouping of similar objects, ideas, events, people. So when we're looking at chairs, what is your concept for a chair? How do you define a chair? Something you sit on. And maybe you also add that it has to have a back to it. But does it have to have four legs? Does it have to have arms? Your concept can be fairly broad. We can organize concepts into hierarchies. So you have a concept of animals. We can divide that into domesticated and wild animals. We have concepts for dogs, cats, cows, and we can divide dogs into mixed breeds and pure breeds. So concepts break down into lots of deeper information. Sometimes we form our concept with definitions, and usually our definition includes a prototype. So, for example, when we think of a triangle, we often think of the ones that just have three sides, and well, they all have three sides if they're a triangle. But you think of an equilateral triangle, you may not be thinking of one that has obtuse angles. Or when we think of our prototype for a bird, you may be picturing a robin or maybe a cardinal or a blackbird, but often when somebody just says bird, what first comes to mind is not usually a penguin or an ostrich. So concepts are usually linked with prototypes. So let's move on to problem solving. Some different strategies. We'll look at each of these. First, it's trial and error. We do this all the time. You try one thing, it doesn't work. You try it out, something else. It's random, haphazard. When you're looking for outfits in your closet, it's a lot more random. You may start from left to right, or you may just randomly pick something and try to see if that would be what you'd want to wear. Going through a maze, fairly random. An algorithm is kind of the opposite of random. Algorithms can be very time consuming, but they consider all possibilities before they arrive at a solution. Computers use algorithms, and they're able to do that very quickly. It's more systematic and less random. But if you wanted to do a real life algorithm, let's say you were going to the grocery store and you wanted to look for something specific. Let's go with duck sauce. So duck sauce is basically like sweet and sour sauce. People like to dip egg rolls in it. So with an algorithm, instead of just going straight to where you think you would guess where it would be, you're going to start on the first row and you're going to look at the first shelf and you're going to look at every item on that shelf, then the second shelf, then the third shelf, the fourth shelf, and you're going to go systematically through every single aisle and every single row. And eventually you're going to get to the duck sauce. Because you are checking every single option. It's going to take you a long time, but you're going to get there. You're very likely to get to a solution. But in real life, we don't want to do that. That takes forever. So instead, we can use a heuristic, which is a guiding principle, a rule of thumb. They're thinking strategies. They help us to make judgments, solve problems more efficiently. They're less time consuming, but sometimes they're wrong. So they're a little more error prone than algorithms. So I know that duck sauce is usually on the Asian aisle. So I'm going to look for the row that says Asian and look for it there. And in theory, it should be there. But maybe that store is weird and they instead put their duck sauce next to the ketchup, which is weird. They shouldn't do that. But not every store has an Asian aisle. But it could be wrong. When I'm using my heuristic and I'm using that shortcut, it's not always right. An algorithm, you're going to get the right answer, but it's going to take you forever to get there. We've got two specific types of heuristics where you're making judgments based on other information you have. With a representative heuristic, you're judging the likelihood of something based on how well they represent or match a particular prototype. So let's say you meet a slim, short man who wears glasses and he likes poetry. What do you think his profession would be? Do you think he is an Ivy League professor, like a Harvard professor, or a truck driver? Now, he fits my prototype for professor. So I'm thinking professor. But probability says that that person is more likely a truck driver. Just because statistically there are way more truck drivers in the US than there are Ivy League professors. So we could be wrong, but we're making our guess based on what most represents our prototype. When we're looking at this picture, do you think this guy is more likely to be a criminal um, or a librarian? Or is he both? A librarian who is a criminal. You have a prototype in your head. Oh, I think, based on movies I've seen, he's got a face tattoo. And he's quite heavily tattooed over here. And he's already wearing an orange jumpsuit. So I think he's already a convicted criminal. That could be wrong. So representative heuristic, you're basing it off of a prototype that you already have. Another type is the availability heuristic. And in this case, you're basing your assumption or you're making your judgment off of how easily relevant examples come to mind. But this one can also lead us astray. Whatever increases the ease of retrieving information increases its perceived availability. So if we ask some people, what do you think the violent crime rates are like in your area? Most people tend to overestimate it. And that's because what do you see on the news? You hear more about the crime, the violent crime, than the days when there's not crime. So you could be wrong, but it still reminds you to be safe. But you're basing it off of what you most recently heard, what is most available to you. Where do you get that information? How is retrieval facilitated? So it's often how recently we have heard about the event, how distinct it is, how correct it is. That maybe you just watched Shark Week on TV, and though shark attacks are not common, especially in Texas, or at least like in lakes, you're scared to go swimming. So what comes to mind is deemed significant, though sometimes it is incorrect. You base it off of information you have readily available. I'm not really going to talk about insight much because we've had this in previous chapters, but this goes here under problem solving, that sometimes it's just that sudden novel realization of a problem. We've mentioned this before too as well, that brain imaging and EEG studies show that the right temporal cortex literally lights up. We have extra neural firing there when we have that aha moment. But what about things that get in the way of solving problems? So these are some obstacles in problem solving, mostly cognitive. The first is confirmation bias. It's your tendency to only want to search for information that confirms your personal bias. So maybe we have a teacher who thinks Asian students are the best at math, stereotype. So he only recalls the Asian students who excel at math and he forgets the ones that don't. So he's only really thinking about information that confirms his view. This goes a lot with politics. A politician who only uses statistics that benefit his campaign, or you decide that you like one politician and not the other, and you tend to only read news stories or follow news channels that confirm your bias. Fixation is another problem solving barrier. It's an inability to see a problem from a fresh perspective, that you only can really kind of see one way of solving it. And when we're stuck on that, we call this functional fixedness. So classic textbook examples, I'll show you a couple here. The matchstick problem. How could you arrange 6 matches to form 4 equilateral triangles? Well, most people, I mean, if we were actually to try this in class, they're going to lay them on a table, maybe make a couple 2 triangles, and then figure out how can I get 4 out of that. What they don't consider is going a 3D route here. Most people won't think that way, that they're stuck on laying the matches flat. The candle mounting problem. Using these materials, how would you mount the candle on a bulletin board? Some people think, well, maybe I can melt it down a little bit and then stick it, or maybe somehow melt it down and then the wick will be longer. But instead, you can actually use the thumbtacks to put in the match box and then put the candle in there. Most people aren't going to think of that because you're fixated on using things in the normal way that they're used. So, functional fixedness is when you can't find other ways beyond the normal way you use something. Overcoming functional fixedness is when you're able to see things from a fresh perspective. Some examples here: can't find a boat? Just get a dining table, flip it over, add a motor. No pot to boil some hot dogs in? Put them in the coffee pot. You need something to hang jewelry on? That's part of a rake. So all of those overcoming functional fixedness. Mental set. This is when we are set in our mental ways. We do things the same way we have always done. We approach things from a certain way because that's the way we've always done it in the past. Maybe mom always makes her Thanksgiving turkey the same exact way, even though it's a little bit dry. But she is mentally set in her ways because it has worked before. Each day we make hundreds of judgments and decisions, and a lot of them are based on intuition, and they really don't have a lot of systematic reasoning to them. Some other problem solving barriers: the gambler's fallacy. Fallacy means false belief. Is a false belief that your probability of an event in some kind of random sequence goes up when it hasn't happened in a while. So, for example, they think the longer something doesn't happen, the more probable it's going to occur next time. So, this family has 5 boys. Mom is pregnant again. They think for sure it will be a girl this time. False. In fact, it's still the same odds, 50-50. It's going to be a girl or a boy. If you toss a coin 20 times and the first 19 times it's heads, you think it's got to be tails this time. It's been heads all the other time. It's got to be tails. False. It's still a 50-50 chance it's going to be heads or tails. But that gambler's fallacy makes us feel like I'm going to win. That's why people keep playing in Vegas. I haven't won in a long time. I've got to keep playing. For sure, I'm going to win this next time. Doesn't work that way. The conjunction fallacy, to me, this one's a little bit tough to explain and understand. The error in which you believe a combination of 2 or more attributes is more likely to happen together than each of those on their own. So you tend to assume that specific conditions are more probable than general ones. So, for example, we've got Linda. She's 31 years old. She's single. She's outspoken. She's very bright. And she majored in philosophy. She was deeply concerned with issues of discrimination and social justice, and she even participated in anti-nuclear demonstrations. So which do you think is more probable about Linda? That Linda is a bank teller, or that Linda is a bank teller and is active in the feminist movement? Most people are going to choose the second one because it's adding all that stuff about the feminist movement. But in reality, those are more probable when we look at them separately. Just because our odds go up, there's more opportunity for other things to happen there. But we tend to look at two things together, specific things. That's the conjunction fallacy. Overconfidence is another barrier to problem solving. We have our intuitive heuristics, we have confirmation of beliefs, confirmation bias, and an inclination to explain our failures, and those all increase overconfidence. And overconfidence is just what you think it is. You are too confident. Your tendency to overestimate the accuracy of our beliefs and judgments. How many times have you said, my homework's only going to take me an hour tonight. I'll be able to go out with my friends. 3 hours later, you're still there doing your work. You are overconfident. Exaggerated fear is the opposite of overconfidence. They're usually unfounded. For example, 9/11, after the 9/11 attacks, so many people were scared to fly. In reality, it was actually a safer time to fly because security was so high. Framing is how we describe a scenario in order to make it fit our motives. Decisions and judgments may be significantly affected depending upon how an issue is framed. So when we're selling ground beef, do we say it's 25% fat or 75% lean? Do we say 2% of high school students drop out, or do we celebrate 98% of high school students graduate? This happens a lot in politics. A headline here: the Trump disapproval rating is up 63%. Same statistic, framing it differently: Trump approval rating is steadfast, with 37% being loyal and continuous by his side. So it's that same stat, but framing it differently. The belief perseverance phenomenon, it's our tendency to cling to our beliefs even in the face of contrary evidence. In politics, if you see that a country is hostile, then you think everything that they do is a sign of hostility. You decide you don't like somebody, everything they do is annoying to you. Even if there may be some kindness things that they do there, you keep your beliefs. They persevere no matter what. This is also part of that confirmation bias. Our last two, and these aren't necessarily problems, they are more strategies to problem solving. The first is divergent thinking, diverge when things separate. And this is basically brainstorming. You generate many unique creative responses to a single question or problem. Maybe you're at the point where you are starting to brainstorm. What are you going to do after college or after high school? So you visit a college fair so you can look at all your options. Eventually, though, convergent thinking needs to happen, where you try to find a single correct answer to the problem. And this is narrowing down your choices to one. Everybody's got these little signs nowadays when they get accepted to a school. All right, that's it for Flip Notes 5-5.